about Java memory management in Kubernetes and how painful it can be, and maybe some of the things that you can do to make it a little bit less painful. Want to give a shout out to my coworker, Sonali, who you can't see on camera, but is behind the scenes operating our virtual studio. Thanks so much, Sonali, for being here to do that. I have a couple of slides that we'll start off with just to kind of set the table a bit, and then we can dive into questions, storytelling, whatever people have ready to go. So this is Ask Me Anything about Java and Kubernetes. By default, a lot of the questions that we've gotten around that are around memory management, but that's not necessarily the only thing that we're willing to discuss today. I am not necessarily going to be able to give an answer to every single question that might conceivably be asked, but I'll do my best to at least say, I don't know the answer, but I can give you a pointer to where you can find it. So just to introduce myself, my name is Joe Thompson. I'm a technical product marketing manager for Platform 9. I've been in IT for almost 30 years. We're about a year and a half away from that 30-year anniversary. That's a big one. And I've been working in the cloud native ecosystem, OpenStack and Kubernetes, and a few other virtualization and container-based solutions since about 2014. So, and also I want to put this up here too. If you're on our live stream, whichever platform you are on, you can add, whether it's YouTube or whether it's LinkedIn, you can ask questions there, and we'll try to keep an eye on those as best we can. But we have started using this community Slack for these live streams. So that's the one that primarily I'm going to be paying attention to. And Sonali will feed me questions if they come in from other sources. But like I said, the Slack is going to be the primary venue, and specifically the AMAA channel on that Slack. So I'll leave that up there, that QR code up there and that URL up there for a minute so people have time to scan the QR or type the code in. We have a bunch of channels on that Slack, and it's we're working on developing that as one of our primary community avenues. Can we put that slide back up there real quick, just so people have the QR code if they need it? There we go. I'm going to give that just a few more seconds, and then I'll move on with the slides. But yeah, we're working on developing that community Slack as our primary venue for interfacing for live streams and other events like this. So moving on, let's actually talk about Java, and specifically Java memory management. It's pretty simple, or at least it looks pretty simple. You've got the Java runtime environment, which runs the Java virtual machine. That's part of the JRE. The other place that the JVM shows up is if you're actually developing Java and you have a Java development kit that also has a JVM embedded in it. But either way, that JVM is what's running your Java code. And memory is allocated to the JVM as it needs it for the running Java app. So pretty much like any app would allocate memory. But then it gets complicated because with a typical OS process, oh, can we get the slides back up there? With a typical OS process, your application, whatever it is going to allocate memory as it needs it. It's going to deallocate it as it doesn't need it anymore. And the OS then gets that deallocated memory back to assign to other things. But the JVM doesn't really do that. The JVM kind of operates on the principle that if I needed memory once, I'm likely to need it again in the future. So why give it back and risk not being able to get it back when I need it? So the JVM typically does not, by default, release that memory back to the operating system. Internally, for its own memory management purposes, the JVM will do what's called garbage collection. And so it's going through and it's identifying memory that is not used anymore by any objects of the running Java app, and marking that memory as available to itself to reassign to the application later if needed. But it does not release that memory back to the OS typically. And because garbage collection itself can be disruptive to applications, in fact, most garbage collectors have a phase they call stop the world, which literally means the application is completely halted while that phase of garbage collection proceeds. So your application is not processing anything internally. It's not responding to any external requests. It's just paused until that phase of garbage collection completes. And that's very disruptive and can cause cascading effects with other things that depend on that app. So the JVM doesn't do garbage collection generally unless it hits a limit. It's unable to allocate any more memory. It can't get any more memory from the OS. It doesn't have any more memory that it already knows has been previously garbage collected that it can now reallocate to the running app again. Then it will go through. If it's exhausted both of those, it will go through and try to garbage collect again. But it tries to not garbage collect if it doesn't have to. Now we start getting into the really complicated part. Garbage collection only affects a specific area of memory within the JVM. That's a memory called the heap. Now, the JVM has other areas of memory that it uses for other purposes. The JRE, the runtime that runs the JVM, also has memory that it uses outside of the JVM. And there's a whole bunch of parameters that you can tweak to control how this other memory is allocated, how much heap is allocated relative to these other things, how these other things are handled when memory gets tight. It's this entire constellation of command line flags and things that you can do internally that control the behavior of the JRE and the JVM. It's a serious rabbit hole. You literally could write a book. I'm sure multiple people already have. So you get this tension between, I want my application to perform, which means that I don't want long pauses for garbage collection, but I also want to make sure that I'm efficiently using memory on the machine so that memory doesn't just kind of fall into the JVM and get stuck, right? And so there are all these alternative garbage collectors that have come up over the years that try to draw different balances between application performance and freeing up memory that's no longer used so that it can be reused or even freed back to the OS. And actually, one of those used to be an alternative collector. Back in the day, the default collectors were, if I remember correctly, the serial collector and the parallel collector. Which one you got by default depended on the environment that Java was running in. Was it single processor? Was it multiprocessor? How much memory did it have? And then somebody wrote the garbage first, or G1 garbage collector, as an alternative collector. And it performs so well in most environments that it's now the default collector. You will still get one of those other collectors. I think you can get either the parallel or the serial, depending on the circumstances, if you're in a very tightly constrained environment. But the G1 is now the default for most things because it was just that much better than the former defaults. And this is the last slide that I have, and then we can jump into questions or storytelling or whatever. I remember this all too well. When people started trying to run Java apps in Kubernetes, and in Docker too, even before Kubernetes came along, there was a problem, which was because of the way the underlying machine's parameters were exposed inside the container, the JVM what happens on startup by default is the JVM says how much memory is available. And then by default, it will pre-allocate a certain portion of that. I think it is or was 25% of available memory. It will just pre-allocate to itself, period. Well, if you see the memory, the entire set of memory of a 16 gig machine or a 32 gig machine or a 64 gig machine, but your container is running with a limit of 1 gig, then the JVM would just immediately try to allocate, 4 gigs or 8 gigs or 16 gigs and immediately get out of memory killed. And so that was probably one of the most common questions back in the day was, hey, everything works great. I've figured out how to build Docker containers for my apps, but I put this Java app in a container, and as soon as I run it, it OM kills and dies. What's going on? Well, that's what was going on. And it took until they brought this out with Java 10, and then they backported it to Java 8. So sometimes you'll see people say this has been there since Java 8. It wasn't in Java 8 originally, but it was backported there from Java 10. There is now container awareness in the Java runtime. So the Java runtime now sees not the full amount of memory available to the OS, but the amount of memory that its container limit is set to. So, and if you don't set a container limit, then by default, that will be the full amount of memory available to the OS. But that was a problem you already had anyway if you weren't setting container limits. It's those people that were setting container limits and going, wait a minute, I thought, it doesn't actually use that much memory. Why is it suddenly falling over and dying as soon as I start it up? Those applications now behave the way you would expect them to from Java 10 and now Java 8 on. So that's all I have as far as slides. I don't know if we have any questions from the peanut gallery. I don't see anything in the AMAA channel yet. Maybe there's some people still working on getting joined to that. So Nali, we got anything coming in? If we don't have anything, not yet. Okay, nobody's asked any questions yet. So I don't know. Let me just talk a little bit about some of the Java issues that I've seen. I remember one time, this was actually pre-Kubernetes. This was working in a VMware environment. And I was supporting a developer team, and they had Java memory management problems like you wouldn't believe. And the biggest problem they had was that their application, they kept thinking of it as a memory leak. And at the time, this was almost 15 years ago. At the time, I was inclined to believe them because they were Java developers and I wasn't. So we were looking at their application, and I remember at one point they said, well, okay, we don't want to use the default Java runtime environment that's bundled with Red Hat Enterprise Linux anymore. We want to use the latest, very latest release from upstream, from the OpenJDK project, which meant that I would have had to sit down and package it. And I said, well, okay, what is the actual problem? Well, our application is consuming memory and it's not releasing it. And so eventually it just consumes all the memory on the OS and the application gets out of memory killed. Okay, so what is going to fix that in the latest release? The answer that I got was, well, we don't know. We just kind of hope that the new version of the JVM will handle memory better in some way. And it was a long conversation. I had to explain to them that, I'm not excluding the possibility that that might be the case, but there's a large amount of work involved in upgrading the JVM to something that isn't included with the OS. There's an even larger amount of work involved in self-packaging it so that we can do those upgrades cleanly in the future. And so I need some kind of justification for why, to my management, for why I'm putting in this level of work to package this thing up, as to why you can't use the default in the operating system. Well, they didn't have an answer for that. So it was a constant ongoing thing of, well, we want to upgrade our JVM. Why? We don't know. And that was something that I saw later on also with Kubernetes as well. There was this idea that Kubernetes orchestration would magically fix your application management issues. And I did see that with some people. They said, oh, okay, so if I put a memory limit on a container in Kubernetes, then that's going to actually control how much memory my application uses. No, it doesn't control anything. It just says there's a limit, and if your application hits it, it will be terminated. So that was something that people took a while. I remember around 2015 or so, Kubernetes was a year old. 2015, 2016, it's a year or two old. People haven't even figured out what you can run on it yet. Can you run a database on it? Back then, it wasn't a great idea. Running Java apps on it wasn't a great idea because of the memory awareness issue. So that was something that took a while to shake out. I think the memory awareness issues in Java finally got shaken out. If I remember correctly, it was about 2018 before enough people were using recent enough Java to where that memory did not become an issue. And let's see. I'll just pause there for a moment and run through and see if anyone is. Don't see any comments here. Yeah, so Sonali just put this caption up here. I did write this blog post. It was actually a little bit the genesis of this live stream about Java memory management and containerized environments, which means Docker, Kubernetes, other containers as well. Things like if anybody has ever run Java on DCOS, those can be somewhat challenging to run. And again, it's because of the container memory awareness. Any containerized environment, you have these different knobs you can twist and switches you can flip for Java. And so I wrote this blog post. It's not intended to be an exhaustive overview of everything, but it kind of introduces a lot of the same concepts that I put on the slides that I showed earlier. And it also gives you some pointers to other things to read. There's a few other articles. There's some things that maybe we can put up as captions shortly that people can read. There's a white paper from Oracle. It's a little old now, but it still dives into a lot of the same concepts of memory management, garbage collection, and how you can properly manage your garbage collection to tweak your applications better. So yeah, definitely check out that blog. I actually had somebody, when I posted that blog in the Kubernetes subreddit, somebody commented on it and said, I didn't see the term native memory in here. And okay, I didn't use the exact term native memory. I knew what he was driving at when he posted that comment. And like I said, I didn't come at this from being a Java developer. I came at it from being a system administrator. So I had to kind of learn some things over the years, bits and pieces about Java and how you run Java in different environments. So native memory was something that never really hit me, but I understand now that it's a very common term people use, and it just means the memory footprint in the underlying operating system. So I never use the specific term native memory, but yeah, the concept is in there. It's funny because every time you go dig into, and I found this out when I was writing that blog post, every time you dig into Java memory management in any environment, you'll run across a whole ecosystem of blog posts, articles, white papers, books, additional tools, and they all promise like, this is the one knob, this is the one thing, this is the one setting that you need to know. And the thing is, there's about, I think I stopped counting around 10 or 12, the one setting you need to know. It's like, okay, if somebody had said, these are the 10 settings you need to know, but then of course, there's more than 10. There's probably 100. And depending on what your application is doing, depending on what environment that application is running in, that one setting may be different for that app in that environment. There may indeed be one setting you need to tweak to make things just run perfectly, but it may be different depending on what the thing is. Random story time. I had a similar situation to that. I was sent out on a performance tuning engagement once. This was when I was working for Red Hat. And there's a whole bunch of knobs that you can tweak for performance tuning in Linux generally. And so I went out to the customer site and I said, all right, let's try this. Literally the first thing I tried made their application run perfectly, completely. Not because I thought for any particular reason that was the first thing to try, just because I tried it and I happened to get lucky. But the funniest thing about that was after that, I kept getting calls from consulting man. We had our consulting arm that I worked in. I kept getting calls from consulting managers going, hey, I heard you're really good at performance tuning. I'm like, no, I got lucky once with performance tuning. That doesn't prove that I'm actually good. So, if I'm the one who's available, yeah, go ahead and send me, but don't overpromise. And Java is kind of the same way. In some cases, a lot of the time, there are 20 things that we think might be worth trying. Let's just go through and try them all and see what makes our application run better, see what makes the environment handle it better, et cetera, et cetera. So it really is in a lot of cases, you aren't going to find a single blog post that says, yes, if your application is this and the environment is this, set these 3 things this way. What you may find is if your application behaves generally this way and it's being hosted in this general kind of environment, here's a few things to try. And then you just have to go through and try them in different combinations and try them with different parameter values and so on, and just experiment until you find something that not necessarily that is perfect, but that works well enough. I mean, that's one thing I learned from performance tuning training when I worked at Red Hat. It was, what are you aiming for? Once you meet what you're aiming for, don't go overboard trying to continually optimize something that's already performing well enough. Get it to acceptable, and then not necessarily stop trying there, but at least don't spend a whole lot more effort getting past acceptable to what you think is perfect when acceptable is enough. And yes, I saw that Sonali posted that QR code that we had earlier. Definitely please join our community Slack. Oh yeah, there it is. Thanks, Sonali. Join our community Slack. We do have, like I said, this AMAA channel. We have some other channels focused around our products and some of our other live streams. If you notice the link for the main page on our website that this live stream is hosted on is called State of Cloud Native. We have other live streams we do there besides these AMAAs. And we have a Slack channel in the community Slack for State of Cloud Native as well. Oh, there's our State of Cloud Native newsletter. So yeah, and of course, we have the other channels that you'll see on Slack, like general and random, that you can't get rid of. All right, I think we're about 20 minutes in. I guess just to kind of wrap up here, the basic thing, the basic idea is when you're going through this, definitely dig into the structure of Java memory management, because like I said, the heap management, the garbage collection within the heap and all of that, you can spend a lot of time tweaking that. And you should spend some time tweaking that if your Java memory metrics are telling you, yeah, you have a lot of unallocated heap. Oh, I see somebody just posted, Spring Boot applications consuming so much memory in my worker nodes, our developers are not performing the garbage collection well. Yeah, it's something you really have to. This goes back to one of the things I've always told people about Kubernetes is you really, really, really cannot do without a test environment. You need a test environment that is as close to your actual production environment as you can get it. And this kind of thing is why. Because to get to a good place with Java, you have to experiment. You have to be able to experiment in an environment where while we're conducting this experiment, it's not going to run away and eat resources and take production down. It's not going to run away and saturate our network and cause people not to be able to load the website. Spring Boot can be especially a pain. I know from talking to people who run Spring Boot apps, this is one thing that happens with them a lot. They have massive memory and CPU requirements on startup. And then once they get into kind of cruising mode, once the startup is done and they've fully loaded and et cetera, once they're in cruising mode, they don't really need as much resources, but they've already been allocated and you're stuck with it. And so the same person's asking, how can I try to optimize it from my end? It's really hard with Java. There are a lot of tools in the Kubernetes ecosystem that are designed around trying to constantly monitor and resize containers. And this is where Kubernetes has evolved over time. So there's a lot of tools that will do things like constantly monitor your containers for memory. And if they see that they're not using all of the memory that they are allocated as a request, they'll resize the request down and restart the container, and the pod will get rescheduled, whatever needs to happen to get that going. That doesn't work as well with Java apps, because once that memory is into the JVM, it's in. As far as Kubernetes is concerned, that memory is consumed. Even if inside the JVM is going, well, 90% of this memory is not even used yet, because Kubernetes doesn't have that level of visibility into Java. It actually is ripe for somebody to come in and kind of give Kubernetes that introspection ability into Java apps and potentially into other, is saying sometimes his Spring Boot apps need 5 CPUs to just boot up. And then you find out that, once you've given that container 5 CPUs, that's it. It's got 5 CPUs now forever. Now, with CPU allocations specifically, there's one thing you can do. It's an experimental feature I shouldn't even say experimental. It's an alpha feature in Kubernetes. You can resize a pod dynamically now if you enable the feature gate to do it. And so what that allows you to do, there's nothing automatic for this yet, but what that allows you to do is say, okay, we're going to give this Spring Boot container 5 CPUs, 6 CPUs, whatever it needs for startup. after startup is done and the CPU, the CPU usage is lower, we're actually going to dynamically resize the CPU request in that container. That is an alpha capability in Kubernetes now, and it does not apply in all circumstances. There are some cases where you cannot do that, and like I said, you have to specifically enable that alpha feature gate. I definitely would not depend on something like that in production, but it is something that is worth being aware of and experimenting with as you go, as that feature develops, because one day, hopefully it will go GA and it'll open up possibilities for exactly that kind of thing. My Spring Boot app needs 8 CPUs to start up, but then it's only using a quarter of a CPU to actually run. What do I do? Well, what you do is just dynamically resize it after startup is complete. Let's see if we got anybody else here. If you're out there lurking and you've got a question, now's the time. Yeah, no sweat. That is something that I just found out about recently myself, that dynamic resize. And like I said, it's an alpha feature. It's not production ready yet. It may be a while before it's production ready. I remember I believe it was pod security policy was alpha, then it was beta, and it was beta for literally like a dozen releases. It was literal years that it was in beta, and people were kind of treating it as though it had gone GA. And then the Kubernetes development project said, you know what? There are things we want to be able to do with this that we can't do with the current way pod security policy is implemented. We're going to deprecate and remove pod security policy. And everybody freaked out. So don't count on in-place pod resizing going GA yet. Don't make solid plans around like, oh yeah, we expect it's going to go GA in 3 versions. But definitely be aware of it. Start experimenting with it. Set up that test environment if you don't have one. Because if you don't have one, guess what? Your production environment is your test environment. And that's not a happy thing for anybody. So yeah, just a quick sum up. Have your test environment set up. Experiment in that test environment with your Java applications. That's also, like I said, the place to experiment with these upcoming in development features that are coming along in the Kubernetes project. So that you won't, you won't be caught unawares if things get deprecated and you were depending on them, but B, also, you will be ready to take advantage of those things as soon as they go GA. So I guess that's about where we can wrap it up. Thanks for coming in. Thanks for asking your questions, Manish. And I'll see you.